Okay, when the other video timed out, we were talking about how we came up with these probabilities. Um, and the easiest one to find was the probability of rolling three sixes. It was they're each a six, and then order doesn't matter if they're all sixes, so it's just 1 6 cubed. The next probability we found was the probability that x is 20, that is we won $20, and that's if we have two sixes, so a 6, and a non-6, and then where one way of thinking about where this 3 comes from is where can this 5 6 go? It can come on the end, it could be in the very front, or it could be in the middle. Those three places are why we multiply by 3, because there's 3 ways that that can happen order-wise. Or another way of thinking about it is the first die could be a non-6, or the second die could be a non-6, or the third die could be a non-6. Another way of thinking about 3 ways for that to happen. Anyway, that's where the 3 comes from. So the next probability we're going to find is the probability that we lose 6. Okay? And that would be that they're all not 6s. And this guy is 125 out of 216. That goes here. And almost always you're going to have this 1 that you're going to have to find using the complement. That is, the probability that x is 6, or that we win $6, is 100% minus each of these other 3 probabilities. So this is 75 out of 216, and that's what we don't want to do, is count those guys up. That would take forever, right? So this is 75 out of 216, and we don't have a ton of room here, but we want to find the expected value. So the expected value of x is, that's a capital X, winning $50 times its probability plus winning $20 times its probability plus winning $6 times its probability plus losing $6 times its probability. So that expected value is 0.23. So kind of a little note about this. If the expected value is positive, then the casino loses money. If this is positive for the player, then the casino loses money. Okay, how do we find the standard deviation? Well, we're going to do this one by hand. So first we're going to find the variance. That's 50 minus this expected value squared times the probability of getting a 50 plus 20 minus 0.23 squared times the probability of getting a 20 plus the 6 minus 0.23 squared times its probability, which is 75 over 216, plus negative 6 minus 0.23 squared times its probability, 125 over 216. You might go, well, right in here, that should be a plus, right? Yeah. No, I'm sorry, it isn't. It's a minus. We're all good. It's always the square of the differences times the probability. Okay, so this is 72.63, but this is variance, so we want the standard deviation, so we're going to take the square root of this guy. So the standard deviation is 8.52. So most of the time, your wins or losses are going to be, when you play the game, most of the time your wins and losses are going to be within $8.52 of winning 23 cents. Okay. An insurance company estimates that over the course of a year, a certain type of person has a 0.5% chance of getting into an accident that costs $100,000 and a 2% chance of getting into an accident that costs $10,000. How much should the company charge this person for a year of coverage so that they make an average profit of $100 per person insured? So the people that do this for a living and actually figure these probabilities out, work for insurance companies, are called, senior moment. It's too early for that. They're not accountants. I can't remember. It'll come to me in a minute. Okay, we're going to identify X as the company profit. Okay, so we want the average profit to be $100 per person insured. So E of X, we want to be 100. If we let P be the price charged per year, which is a premium, aka premium, then our probability distribution, which is just a chart of probabilities, is we could lose $100,000. We could lose $10,000. $10,000. Is that right? 10,000, yeah. Or we could make P, right? So this is if they get into a terrible accident, this is if they get into a bad accident, and this is if they get no accidents, then it doesn't cost us anything at all. We're just earning their premium. Okay, let's talk about the probabilities associated with these. This is a 0.5%, that's 0.005. This is a 0.2%, sorry, 2%, so 0.02 in decimal notation. And then this is the difference. This is going to be 1 minus 0.005 minus another 0.02. So that's 975, 0.975. Okay, so we want this expected value. We know it's going to be equal to 100. And that's going to be equal to losing 100,000 times its probability plus losing 10,000 times its probability plus 0.975p. We're going to solve this thing for p. This is negative 500. This is minus 200. So this is minus 700. If we add 700 to both sides, we get 800 is equal to 0.975p, and if we divide each side by 0.975, p is equal to 820.52. That's yearly. premium. Okay. How much profit should the company expect if they insured 100 of these drivers? Well, if we're expected to make $100 off of each of the 100 people, that's $10,000 a year. So, if insurance companies are only making $100 a year off of people, they can't survive on that, right? So they better try and figure out if they're only earning $100 a year off of folks on average, right? Then they better try and figure out how to get this number of people that they have insured, these number of drivers they're insuring, up. Otherwise, they're not making enough money, right?